Assalamualaikum warahmatullahi wabarakatuh. My name is Nurul Fatihah binti Muhammad Fauzi. My paper code is CT-00102 and I'm from University Technology. Today I'll be presenting my paper entitled Assessment of Mangrove Replanting Site at Kampung Tanjung Kepah, Lekeh, Perak. So basically, I'll briefly explain about the introduction and background study of my project. So basically, my project is about mangrove. Mangrove are formation of salt-tolerant shrubs or trees that inhabit the intertidal zones of sheltered coasts. They secure the land from the seas and can withstand strong wave action. Ever since the occurrence of Indian Ocean Tsunami 2004, people started to recognize the importance of mangrove as natural coastal protection. However, mangrove are disappearing at an alarming rate due to impacts of natural processes and anthropogenic influences. There are a lot of mangrove restoration efforts have been done, but most of them are failed. A thorough appreciation of the site condition is mandatory to ensure high survivability rate of the young mangrove saplings at their planting sites. So basically my study site is at Kampung Tanjung Kepah. There are a total of 3 mangrove replanting attempts have been done at Kampung Tanjung Kepah between 2008 and 2015 by Forestry Department. Unfortunately, all efforts have failed due to some unexplored reasons. Hence, it is crucial to undertake a site investigation to determine the root cause of the previous mangrove replanting failures at Kampung Tanjung Kepah. So, as I mentioned before, there are 3 mangrove replanting programs that are conducted at Kampung Tanjung Kepah. So, as you can see, all of them were unsuccessful. So moving on to the methodology, for data collection, I divided into 5 key activities. First, mangrove tree assessment. So the purpose of this is to evaluate the characteristics and distribution of the existing mangrove forest at Kampung Tanjung Kapah. The major parameter is the species, age, basal area, height of tree, diameter of breast height, width, height, and diameter of trunk and root. So I managed to get 32 trees to be sampled using leveling staff, measuring tape, and digital caliper. So there are 2 transect lines were set up here, transect 1 and transect 2. Each transect line was set up with 3 standard plot size 20 meters and 10 meters. So this is the geometry parameters of the tree taken during the field assessment. For current measurement, the purpose of this is to evaluate the physical characteristics of surface current flows. So the measured parameters is water depth, velocity of current flow, and also the direction of current flow. So there are 3 points C1, C2, and C3, and the water depth is measured using a leveling staff, and dye is used to identify the direction of current propagation. For soil sampling, the purpose of this is to evaluate the physical analysis of soil, and the measured parameter is the pH, salinity, temperature, and also sieve analysis. There are 5 points taken for S1, S2, S3, S4, and S5. For soils, the in situ testing for pH, temperature, and salinity of soil are measured using the soil meter, and then the soils are transported to the lab to do the sieve analysis to know the particle size distribution by using the oven and also the sieving machine. And then for water sampling, the purpose of this is to evaluate the physical analysis of water. The measure parameter is the pH, salinity, DO, turbidity, temperature, TDS, and also TSS. There are 10 points, which is from Kimi Shele here to Sungai Tiram. Each location is labeled as W1 until W10. So for water in situ testing, the water quality parameters are measured by using the PRO-DSS multi-parameter for water quality testing. And for topography detail survey, the purpose of this is to determine the topographic mapping and elevation. The measure parameter is the real-time position and coordinate of each feature on the site area. So I managed to get 80 points using the RTK equipment. So to ensure my point is stable and not moving, I connected my point with Pusing station and also Teluk Intan station to ensure that my point is accurate and stable. Then moving on to the results and discussion. For mangrove distribution, the major species of Kampung Tanjung Kepah is Soneratia alba 56%, followed by Avicennia alba 34% and Reservoir apiculata 10%. So the mangrove species is depending on the mangrove zonation. So most of the time Soneratia alba and Avicennia alba species occupy the seaweed zone. And then the age of existing mangrove trees at Kampung Tanjung Kepah are ranging from 3 to 20 years old. I divided the ages into 3 classification. First mature 16 to 20 years old, middle age 7 to 15 years old, young sapling to 3 years old. So the existing mangrove trees at Kampung Tanjung Kapar are dominated by middle-aged trees, which is 56%, while mature and young trees have the equal distribution, which is 22%. For soil physical properties, as you can see here, S1, S3, and S4 consist of silty clay soil texture, while S2 and S5 soil distribution consists of sandy clay soil structure. So different soil structure give different impact to mangrove growth. For soil pH, mangrove grow best between 5 to 6.5. So as you can see, all the soils are in a good range of pH. And then for temperature, S1, S3, and S4 are quite high compared to S2 and S5 because they are exposed directly under the sunlight without any tree protection. For salinity, S5 contains the highest salinity because there are a lot of trees there. The higher the mangrove density, the higher the salinity. Moving on to water physical properties. So there are a lot of parameters here. So I've been pointing out just the important point. The water W5 is more alkaline compared to others and might be the reason why the mangrove saplings could not survive. So the pH cannot be too alkaline and also cannot be too acidic. So it must be between the range 5 to 6.5. Um, and then W5 also holds the highest salinity because W5 has the highest density of mangrove trees, which requires more saline water to survive. W5 is where my set area is. For surface current analysis, water flows in mangrove areas are strongly influenced by the distribution of mangrove trees and wave actions. So current velocities of mangrove floods are usually very, very low, which is less than 10 cm per second. The surface current flows at C2 and C3 are quite high due to strong wave action. There is no mangrove at all that can act as obstacles at the area. But at C1, the current flows decrease very rapidly across the flats, as dense growth of mangrove here can slow down the current flow. And then for topography detail survey, I get this finding from ArcGIS software. So from here, it is obvious that the failed mangrove replanting area has much lower elevation compared to other topography area around it. So here the slope elevation are ranging from 1.9 to 2.4 meters. Mangrove cannot establish below mean sea level (MSL). Since the level of the eroded mudflats here are generally below MSL, the efforts were not successful. So mangrove grow very well between MSL and mean high water spring. And also it can provide adequate protection to the pine. So for conclusion and recommendation, it is essential to preserve the valuable mangrove forest to protect our beloved nation from tsunami in the future. So in order to preserve the mangrove and ensuring the successful mangrove restoration effort, detailed study upon the site condition is very, very important. Based on the field assessment conducted at Kampung Tanjung Kapah, the results shows that the mangrove planting failures might due to shore slope and topographic condition. The slope elevation is too low and consists of muddy soils. Hence, the survivability of young mangrove saplings are rather low as their roots are not strong enough to support them. It is recommended to install coastal protection such as geotextile tubes to allow the sediment stabilization first before pursuing any mangrove replanting activities. That's all from me. Thank you.